Yellowstone National Park could be sitting on a time bomb. There is a supervolcano underneath the national treasure.
Deep within the serene beauty of Yellowstone National Park, a silent and unseen force is stirring. Hidden from the naked eye, a massive dome-shaped uplift is expanding at an alarming rate. This unexpected geological activity, combined with recent bizarre animal behaviors, paints a picture of a landscape on the brink of profound change. As experts scramble to decode the implications, one thing is clear. Yellowstone is hiding a secret of monumental proportions, and preparedness and planning are now more crucial than ever. The question remains, is Yellowstone's supervolcano about to awaken?
This chamber is absolutely packed full of magma, and an eruption from this could really cause widespread destruction all across that region.
Today, we've compiled 20 intriguing facts that will help you give an answer to this question. Mysterious animal behaviors. Recently, Yellowstone National Park has witnessed a series of unusual animal behaviors that have left scientists and park officials intrigued. Herds of bison, typically known for their predictable migratory patterns, have been seen moving en masse away from the park's center. Elk and deer, too, have displayed erratic movements, often venturing into areas they usually avoid. Bird species native to the park have been observed flying in atypical patterns, with some even leaving their established territories. Historically, animals have acted as the Earth's intuitive barometers, their behaviors often signaling impending environmental shifts. Their heightened sensitivity allows them to detect underground tremors, shifts in gas emissions, and other subtle changes that often precede significant geological events, a testament to nature's early warning system. The urgency and scale of these wildlife movements in Yellowstone are alarming. It's as if the very soul of the park is rumbling, sending shockwaves through its inhabitants. If animals are indeed reacting to impending volcanic activity, then their desperate exodus paints a chilling picture. Yellowstone might be on the brink of awakening, and its fury could be unimaginable. Animal whisperers. Long before the advent of modern technology, indigenous tribes around the world have been the original custodians of nature's secrets. These tribes, deeply rooted in their lands, have always possessed an uncanny ability to read the subtle cues of their environment. The Shoshone, Bannock, Crow, Blackfeet, and Nez Perce are among the tribes that have called the Yellowstone region home for millennia. Their intimate knowledge of the land, its animals, and its geothermal features has been passed down through generations, offering a unique perspective on the park's environmental shifts. One of the most profound insights from these tribes was their understanding of Yellowstone's volcanic nature. The Shoshone and Bannock, who frequented the park's geothermal areas for ceremonies and medicinal purposes, recounted legends of the ground breathing, a reference to the geysers and hot springs. They spoke of times when animals fled the region and the earth rumbled more than usual, suggesting that the tribes had witnessed minor volcanic activities or precursors to potential eruptions. The Blackfeet, known for their storytelling prowess, have tales that hint at a time when the sky turned dark and ash rained down, possibly alluding to past volcanic eruptions. Their stories served as both historical records and cautionary tales, emphasizing the need to respect and understand nature's signs. Could the very ground we stand on be moments away from unleashing its wrath? Yellowstone's rising secret, the dome. In the depths of Yellowstone's vast wilderness, a startling discovery has emerged that has left even seasoned geologists astounded. Beneath the mesmerizing vistas and steaming geysers, an enormous dome-shaped uplift lurks, revealing the intense forces churning beneath our very feet. But how did this monumental revelation come to light? The answer lies in cutting-edge technology. Advanced satellite imagery, combined with precise ground-based GPS measurements, unveiled a world previously hidden from human eyes. These tools allowed scientists to map the topography of Yellowstone with unparalleled precision. Measuring the magnitude. As these scientists were analyzing the data they had collected from the park, they began to notice an astonishing pattern. The ground in a specific region of the park was rising, and not just by a negligible amount. Measurements indicated that certain areas had experienced an uplift of several centimeters over a relatively short period. To the untrained eye, this might seem insignificant, but in geological terms, such rapid changes are both rare and deeply troubling. What do the numbers tell us? Initial observations showed that the uplift spanned a staggering 1,500 square kilometers. Within this expanse, the rate of rise varied, with some regions soaring by an incredible 10 centimeters per year. Such rapid deformation is a glaring sign of intense geologic activity beneath the surface. The sleeping giant awakens. But here's the real mystery. This uplift is still increasing in size. What does this mean for Yellowstone and the surrounding region? And what can it tell us about the Earth's inner workings? The answers to these questions take us back to a chapter of Yellowstone's history that's both awe-inspiring and terrifying. Yellowstone isn't just any national park. It's perched atop one of the world's most formidable supervolcanoes. This isn't your typical volcano. It's a geological giant capable of eruptions so vast and catastrophic that they can alter global climates and reshape continents. The pressure beneath. In the last 2.1 million years, this supervolcano has awakened from its slumber not once but 3 times, and the scale of these eruptions is almost beyond comprehension. To put it in perspective, the 1980 eruption of Mount St. Helens released about 1.2 cubic kilometers of material. In contrast, Yellowstone's past eruptions have spewed out over 1,000 cubic kilometers of volcanic material. That's an eruption over 1,000 times more powerful. Now here's the truly shocking part. The pressure buildup we're witnessing might be an indication that the supervolcano is stirring once again. Another volcanic eruption might very well be on the horizon, and when it takes place, the effects will be devastating. While it's impossible to predict exactly when or if this will happen, it's clear that something significant is happening beneath Yellowstone. The question now is, are we prepared for what might come next? The consequences of the uplift. What would happen if the very ground beneath our feet decided to unleash its fury? If the uplift culminates in a volcanic eruption, the immediate vicinity of Yellowstone would face unparalleled devastation. Within a radius of 40 miles, the landscape would be completely transformed. Dense, superheated pyroclastic flows, which are fast-moving currents of hot gas and volcanic matter, would incinerate everything in their path. Forests, wildlife, and any infrastructure would be obliterated almost instantaneously. The ground would be buried under a thick layer of ash and volcanic debris, rendering it unrecognizable. Ash fall across the nation. Can you imagine waking up to a world blanketed in ash, even if you're thousands of miles away from the eruption? Beyond the immediate vicinity, the eruption would spew vast amounts of ash into the atmosphere. This ash, carried by prevailing winds, could blanket large portions of North America. Areas hundreds to thousands of miles away could receive a few inches to several feet of ash. Major cities like Denver, Salt Lake City, and even places as far away as New York and Los Angeles could be affected. This ashfall would have dire consequences. The ash, being abrasive, acidic, and toxic, would contaminate water sources and soil, making agriculture challenging for years, if not decades. Roads, airports, and railways would be rendered unusable. The weight of the ash could cause buildings, especially roofs, to collapse. Power lines and transformers would be at risk, leading to widespread power outages. In addition, fine ash particles, when inhaled, can pose significant health risks, especially to those with respiratory conditions. The ash can also contaminate drinking water and lead to a range of health complications. Global climate implications. How would nature respond to an event that alters the very fabric of ecosystems? One of the most significant global impacts of a Yellowstone eruption would be on the Earth's climate. The eruption would release vast amounts of sulfur dioxide into the stratosphere, where it would form sulfuric acid aerosols. These aerosols reflect sunlight back into space, leading to a cooling effect on the Earth's surface. Scientists estimate that a large-scale eruption could lead to a global temperature drop of 10 degrees Celsius. This sudden and drastic change would last for several years, leading to what's termed a volcanic winter. The reduced sunlight and cooler temperatures would severely impact global agriculture. This could lead to widespread crop failures, food shortages, and famine in many parts of the world. The cooling effect could alter monsoon patterns, affecting water availability in regions dependent on monsoonal rains. Ecological impact. The eruption would also have profound effects on ecosystems. Ashfall would contaminate rivers, lakes, and reservoirs. This would impact freshwater ecosystems, killing fish and other aquatic life. The intense heat from pyroclastic flows and falling ash would devastate forests. It would take years for these ecosystems to recover, and many animals would not survive the immediate effects of the eruption. Those that do would face challenges due to habitat loss and food shortages. Can we mitigate the threat? Is there anything we can do to prevent or mitigate the effects of a potential eruption? This question has led to some intriguing proposals. The concept of geoengineering the caldera has been floated as a potential solution. This involves drilling into the magma chamber and pumping in water. The idea is that the water would cool the magma, thereby reducing the risk of an eruption. On paper, it sounds like a feasible solution. By cooling the magma, we could, in theory, stabilize the chamber and prevent it from reaching the critical temperature and pressure thresholds that trigger an eruption. However, the practical challenges of such an endeavor are immense. Drilling into an active volcano is fraught with risks. The intense heat and pressure inside the magma chamber could lead to catastrophic equipment failures. Moreover, even if the drilling is successful, there's no guarantee that the cooling would be effective. The sheer volume of magma in the chamber means that an enormous amount of water would be required to have a significant cooling effect. Additionally, introducing water into a superheated environment could lead to explosive steam eruptions, potentially making the situation even more dangerous. Continuous monitoring and early warning systems. Perhaps the most practical and currently implemented preventative measure is continuous monitoring. The Yellowstone Volcano Observatory is a collaboration between multiple organizations, including the U.S. Geological Survey, the University of Utah, and Yellowstone National Park. The YVO continuously monitors the caldera's seismic activity, ground deformation, and gas emissions. By keeping a close eye on these parameters, scientists can detect any unusual activity that might indicate an impending eruption. Another crucial aspect of mitigation is public education and preparedness. The communities surrounding Yellowstone need to be aware of the potential risks and have plans in place for evacuation and emergency response. This includes having designated evacuation routes, emergency shelters, and stockpiles of essential supplies. Regular drills and public awareness campaigns can ensure that people know what to do in the event of an eruption. While it's impossible to predict exactly when or if an eruption will occur, being prepared can make a significant difference in the aftermath. Monitoring Yellowstone, the tools of the trade. Have you ever wondered how scientists detect the minute tremors and quakes that occur beneath our feet? Enter seismographs. These sensitive instruments measure and record the vibrations of the Earth, capturing even the faintest of rumbles. At Yellowstone, a network of seismographs is strategically placed throughout the park. They continuously monitor seismic activity, alerting scientists to any unusual patterns or sudden spikes in tremors, which could indicate magma movement or potential eruptions. How can we know if the ground beneath us is rising, falling, or shifting? With the help of global positioning system stations, these devices can detect even the slightest movements in the Earth's crust. By comparing data over time, scientists can determine if certain areas of the park are experiencing uplift, subsidence, or lateral shifts. Such information is crucial in understanding the behavior of the magma chamber beneath Yellowstone and predicting potential volcanic activity. Gas monitoring, thermal imaging, and hydrological studies. Did you know that changes in gas emissions can also signal volcanic activity? Volcanoes and geothermal areas release various gases, including carbon dioxide, sulfur dioxide, and hydrogen sulfide. By monitoring the quantity and composition of these gases, scientists can gain insights into the magma's depth and composition. Specialized instruments, known as gas analyzers, are deployed around Yellowstone to continuously sample and analyze the park's gas emissions. Yellowstone is renowned for its geothermal features, from bubbling mud pots to erupting geysers. But how can we know if there's a change in the temperature of these features? Thermal imaging cameras come to the rescue. These cameras capture infrared radiation, allowing scientists to visualize temperature changes in real time. Any sudden spikes or drops in temperature could indicate changes in the geothermal system, providing vital clues about the magma's movement beneath the surface. Finally, water plays a pivotal role in Yellowstone's geothermal system. By studying the park's rivers, lakes, and springs, scientists can understand how water interacts with the underlying magma chamber. Instruments like water temperature probes and pH meters help monitor the water's chemistry and temperature, revealing any changes in the geothermal system. The science behind uplifts. But what's driving these dramatic transformations on Yellowstone's surface? At the heart of the matter are geological processes that have been at work for millions of years. The Earth's crust is not a single solid shell, but is made up of several tectonic plates that float on the semi-fluid asthenosphere below. As these plates move, they interact with each other, leading to various geological phenomena, including uplifts. But what's the connection between the movement of these tectonic plates beneath and the uplifts we observe? Here's where things get heated, literally. Beneath the Earth's crust lies the mantle, a layer of molten rock called magma. This magma is in constant motion, driven by the heat from the Earth's core. When conditions are right, this magma can rise, pushing up against the Earth's crust and causing it to bulge upwards. This process is known as magmatic intrusion. The movement of magma also explains why the uplift is in a curious dome shape. As magma from the Earth's mantle rises towards the crust, the pressure that it exerts causes the ground to bulge outwards, creating a dome-like formation. The size and shape of the dome provide valuable insights into the volume and viscosity of the magma, as well as the depth at which it resides. The tectonic tango, plates in motion. Now, you might be wondering, how does this magma find its way to the surface? The answer lies in the intricate dance of tectonic plates. When two plates move apart, they create gaps or rifts. Magma from the mantle can seep through these rifts, leading to volcanic eruptions. But in some cases, the magma doesn't make it all the way to the surface. Instead, it solidifies below the crust, causing the overlying rock to rise. This is one of the primary mechanisms behind uplifts. But magma isn't the only player in this geological ballet. Tectonic activity plays a crucial role in shaping the Earth's surface. When two tectonic plates collide, the immense pressure can cause one plate to be forced beneath the other in a process known as subduction. This can lead to the formation of mountain ranges and, you guessed it, uplifts. Conversely, when plates glide past one another, they carve out fault lines. The tension along these faults can also birth uplifts, especially if one fault edge ascends relative to its counterpart. The role of the hotspot A's for the driving force behind this region's volcanic activity, it's none other than the Yellowstone hotspot. This thermal anomaly, deep within the Earth's mantle, has massively contributed to the park's geothermal wonders. As the North American tectonic plate drifts over this hotspot, it fuels the park's volcanic system, leading to periodic eruptions and the continuous reshaping of the landscape. And recently, scientists made a fascinating discovery that adds a new dimension to the geological wonders of Yellowstone. Using advanced seismology techniques and geophysical measurements, they've identified not one, but two massive magma chambers beneath the park, shedding light on the complex subterranean plumbing system of Yellowstone. The discovery of a second chamber. The first chamber, already known to scientists, has been the primary driver behind the park's famous geothermal features. But the recent discovery of a second, much larger chamber was unexpected. This deeper reservoir, estimated to be more than 4 times the size of the upper chamber, contains a staggering volume of molten rock. But what's even more astonishing is that these two chambers are connected, forming a complex subterranean network of molten rock that fuels the park's geothermal activity. This groundbreaking revelation of dual magma chambers beneath Yellowstone is not just a testament to the park's dynamic geology, but also a stark reminder of the potential dangers lurking below. The sheer volume of magma, combined with the interconnectedness of the chambers, suggests that any disturbance could have cascading effects. With such a vast reservoir of molten rock, the question on everyone's mind is, what are the chances of a cataclysmic eruption? And are we sitting on a ticking time bomb? The stakes have never been higher. The beauty and wonder of Yellowstone may be captivating, but beneath its serene facade lies a force of nature that could change the course of history. Yellowstone's uplift in context. Across the globe, various regions experience uplifts, but not all uplifts are created equal. How does Yellowstone's recent dome-shaped uplift compare to other notable uplifts worldwide? And what can these comparisons tell us about the potential future of this iconic national park? First, let's take a look at the Himalayas. Have you ever wondered how these majestic mountains came into existence? The answer lies in tectonic uplift. As the Indian plate collides with the Eurasian plate, the immense pressure forces the Earth's crust upwards, giving birth to the towering peaks of the Himalayas. But here's the catch. While the Himalayan uplift has been ongoing for millions of years, resulting in mountains that reach the skies, Yellowstone's uplift has shown significant changes in a relatively short span of time. Journeying to the heart of Africa, the East African Rift Valley showcases a different kind of uplift. As tectonic forces pull the African continent apart, a vast valley or rift forms. This rifting process is accompanied by volcanic activity, as magma rises to fill the gaps. But like the Himalayas, the rate of rifting in the East African Rift is relatively slow, spanning millions of years. In contrast, Yellowstone's uplift has been observed over mere decades. Such a stark difference in timescales begs the question, what's fueling Yellowstone's rapid rise? The climate paradox. While the eruption of a supervolcano is undeniably catastrophic, spewing ash and molten lava across vast landscapes, it also carries with it an unexpected silver lining, the potential to temporarily counteract the effects of global warming. A volcanic winter is essentially a short-term cooling of the planet, which, in theory, could provide a brief respite from the escalating temperatures of global warming. Past eruptions, like the one at Mount Pinatubo in 1991, also led to a noticeable dip in global temperatures for a couple of years. However, this cooling effect is a double-edged sword. While it might offer temporary relief from rising temperatures, the long-term implications that we've discussed are far from beneficial. And once the particles settle, the underlying issues of greenhouse gas emissions remain, ensuring that the global warming trend resumes. Yet even in the aftermath of such catastrophic events, nature has an inherent ability to rebound and restore balance. For example, after significant disturbances, many ecosystems undergo a process called succession, where they gradually return to a stable state. This process starts with pioneer species, plants and animals that are the first to colonize a devastated area. Over time, these species pave the way for more complex communities. Moreover, the Earth's history is replete with instances of recovery from mass extinctions and climatic upheavals. The very forests that we see today are a testament to nature's ability to regenerate after ice ages, meteor impacts, and yes, volcanic eruptions. Thanks for watching this episode of Beyond Discovery. Don't miss the video you see on your screen, you won't believe it.